Okay, for this first question then, it says David earns £960 per month. He spends 2/3 of that on rent, electricity and rail fares. He spends £200 on food and saves what he has left each month. What fraction, so when we're talking fraction, we know we're going to have an answer which is like something over something. And of his earnings does David save each month? Give your answer in simplest form. So the first thing we need to do is we need to go and work out how much 2/3 of this amount is, okay? So we've got a calculator for this paper, so we're doing 2/3 of, just means you multiply the 960, and that's going straight into your calculator, okay? So putting that into my calculator, pressure the fraction button, 2/3 times 960 gives me £640, okay? Now the fact that he spends that much means we're going to subtract that off 960. So 960 we're going to take away 640 quid. We are also going to take away £200 because he spends £200. So that's going straight into my calculator. Don't attempt to do this in your head if you have a calculator. It's too easy to lose marks. I'm doing it for safety as well. And I get the answer 120. Okay, so how much does he save each month? In terms of a fraction, it is 120 out of 960. Now that is a fraction, but not as it's requested in simplest form. So what I'm going to do is I'm literally just going to put in 120 out of 960 into my calculator. So 120 out of 960. And my calculator's done all the hard work for me. It's given me 1/8. Okay, now the reason why I've left such a gap in between here is I am going to show you how it's done that, just because it could come up as a non-calculated question quite easily. First thing I've noticed, there's a 0 top and bottom here, so I'm going to divide both top and bottom by 10, so it gives me 12 out of 96, and then they're both even, so I'm going to halve both of them, so I'm going to get 6 out of 48. And then I've noticed that 6 goes into both of those. So how many 6s go into 6? 1. And how many 6s go into 48? And that answer is 8. Okay? The next question, hopefully we're looking at, and I'm hoping you're pausing the video now and having a go yourself, because this really is a subject that you've shown on more than 20 occasions now that you can absolutely nail. I'm going to do it the arrow method. It's up to you whichever method you want to use, but what we do start off with doing is looking for the smallest x, so 10x or 6x, and obviously it's 6x, so we get rid of the smallest x, so whatever I do to one side, I do to the other. So I'm going to get 4x plus 9 is equal to 11. Now I'm trying to get x completely on its own, so get rid of the plus 9 first. So to get rid of plus 9, I'm going to take away 9 from each side. And then I'm going to get 4x, so it's gone now, the plus 9 is gone, but then I get 2 on this side. Now, at first glance, you look at it and think, oh, I can't do that, because to get rid of the 4 with this x, that 4 is times the x, I divide both sides by 4. And then you'd look at it and say, oh, 2 divided by 4 I can't do. Or you might accidentally say it's 2 and it's not. 4 divided by 2 is 2, not 2 divided by 4. Think of it as £2. If I had £2, I wanted to share it between 4 people. Each person would get how much? But don't forget you have a calculator on this paper. So 2 divided by 4 goes into our calculator and tells us x is equal to 0.5. And the question underneath, and again, pause the video, make sure you're having a go at this one first. We should be expanding that bracket, so that 5 times is by the x to give me 5x, that 5 times is by 4 to give me 20, the sign in the middle is a minus, and that is equal to 50. And again, I'm going to do the arrow method, but whichever way you are comfortable with. So I'm going to put them in readiness, and then I'm going to add 20 to each side to get rid of that minus 20, so add 20 to there means I add 20 to there, and I get 5x is equal to 70. And I am then going to get rid of the 5 by dividing each side by 5. And then again, that's going to my calculator. Don't run the risk. You've got a calculator for this paper, and your calculator will tell you it is 14. The next question was the exchange rates. Don't worry about this extra line they're given to an equal sign. That means equivalent to it. It was really nothing to worry about at all. I'm going to write that exchange rate out again, but with a bit more space around it, and I'm going to put the euro sign. And I'm going to put an arrow pointing to there and say times by 1.44, and then an arrow pointing back and saying divide by 1.44. Now again, really you should be pausing this and having a good go at this question. You're more than capable of this. One thing I'm going to try and pick out before I carry on, or before you carry on, and it says 8 hours 30 minutes, and they're talking about speed in miles per hours. That's in hours and minutes, that's in hours, so I need to turn that into hours and minutes. And again, we've done a lot of this recently. How much of an hour is 30 minutes? If it's 30 minutes past 10, for instance, another way of saying that is half past 10, so that would be 8.5 hours. So, if I was to read through the question properly now and try and work out what it wants me to do. It says, Carol goes on holiday. She travels from her home in Wales to a holiday cottage in France. The average speed, so the fact they're talking about average speed again, I'm going to start filling this in. We'd have speed is equal to distance divided by time. The average speed was 38 miles per hour. The journey took Carol 8.5 hours from setting out to arriving at the holiday cottage in France. Find the total distance travelled. So I am coming to my triangle here, and I'm covering up the D because it asked me to find out the distance. So that is speed times time. So the speed, so I'm going to write D is equal to S times T. So the speed was 38 miles per hour times by 8.5 hours. So the common misconception is people accidentally put in 8.3 there. Don't be one of those people. So 38 times by 8.5 gives me 323 miles. Okay, not donuts or bananas or anything, so make sure you write in what unit of measure it is. Next it says, Carol exchanges £400 into euros. How many euros will this get her? So come back to your exchange rate. We are on pounds because she has £400, so put your finger on pounds. Which arrows will we follow? The top arrow. So I need to do £400. I need to times that by 1.44, and that will give me the answer in euros, and that is definitely going into a calculator. So 400 times by 1.44 gives me 576 euros. Okay, so 2 marks there, 2 marks above, lovely 4 marks there. Okay, the next question is a bit more fussy. It says petrol in France costs the equivalent of 16p per litre less than it does at home in Wales. Carol usually pays £1 or 110 pence, so £1.10p per litre at home. How much will a litre, or how much per litre will Carol pay for a petrol in France? Okay, so this is all about breaking this down into manageable steps. We know it costs 110p at home. We know that it's going to be 16% less. So I need to find 16% of that number, and then I need to take that away because it's less. If it was 16% more, I would have added it on. So that is 16% means 16 out of 100, okay? Or I could have said 16 divided by 100, whichever way is easier for you. Or we could have said 0.16, because if you put 16 over 100 into your calculator and press SD, it will come to that. So I'm going to go with the first one I said, 16 over 100 multiplied by 110p, okay? So that gives me, times by 110, gives me 17.6 pence. Now that's how much 16% is. To make it 16% less, I now need to do the 110p. I need to take away that 17.6p. And that is the equivalent of 110 take away answer is 92.4 pence per litre in France. Okay? Now, truth be told, if I look at that question, I went 4 marks. God, that's an easy 4 marks. Have I done everything the question asks? It says, the very final line, it says, how much per litre does Carol pay how much per litre does Carol pay for petrol in France in euros? And I've done my answer in pence. Okay, so I need to change 92.4 pence into euros. So the first thing I'm going to do is change it into pounds. So 0.92. And then you just put on the 4 there. Now, realistically, that doesn't really exist. But if you look at the petrol pumps as you drive past them, it does say point of a pence because you put in lots and lots and lots of litres into your car. So that point of a pence actually adds up to quite a lot over time. Going back to our exchange rate, we had £1 was equal to €1.44. So then to change pounds into euros, we've already stated on the other page that is times by 1.4. So I now need to times that by 1.44 to change that into euros. So 0.924 times by 1.44 comes to 1.33056. And like we said, as you can't really have as you can't really have more than two decimal places in an answer, I would look at rounding that. Okay, so I'd round that to 1.33 euros to two decimal places. Okay, I know I said above that you could have it on petrol stations. It certainly doesn't go as far as to 5 decimal places. Okay, so it's fine to stop there at 2 decimal places, but it's better to leave this answer as your most accurate answer if you can leave that. Okay, but you should get the marks if you treated it as 0.92 to be fair. Lovely question here. We got one of the C grade topics of the week. Please pause the video and have a go yourself. We should be feeling really confident with these sort of questions now. If you do want to hear a hint, the biggest hint I can tell you to do is make a midpoint column and make a midpoint times frequency column, but you really should be pausing the video and having a good go yourself now. So hopefully you pause now and you're just trying to wait and listen to what the answer is. Midpoint, 24. If you're ever unsure, 20, add the 28 on your calculator, then divide it by 2, should give you 24. But make sure that you have pressed 20, add 28, and then pressed equals, and then divided by 2, because otherwise your calculator will do BIDMAS. 29 to 37 should be 33. 38 to 46 is 42. And finally, we should have 51. And under the midpoint column, we are always going to grey out, so we don't accidentally add that up. The next thing we are going to do here is we are going to times together 24 times 13. So 24 times 13 gives me 312. 33 times 32 gives me 1056. 42 times 28 gives me 1176. And finally 51 times 27 is 1377. Okay. So what we need to do now is we need to add up the number of boxes. That's what we call the total frequency. It will usually say in the question, but make sure just for safety, okay? So if you add all these up, it does come to 100. And if you then look at adding up this set of numbers here, 312 plus 1056 plus 1176 plus 1377 comes to 3,921. To work out, oh no, hang on, I've just gone straight into what I thought the question was asking, and I've done something that I didn't need to do at all. Okay, although it is part B. I've started answering part B here, so I'll finish it as I've started it. To work out an estimate for the mean number of matches per box, it is going to be 3921, and then we're going to divide by 100, and that would then be equal to 39.21. And if I were you, I'd always check, does that answer make sense? It lies in between the smallest number, which is 20, and the biggest number, which is 55. So yes, that does make sense. Okay, now let's read part A. It says, one of the boxes is selected at random. What is the probability it contains 20 to 28 matches? Well, if I look at 20 to 28, the chances are there are 13 boxes that do that. So that would be 13 out of, and there are 100 boxes in total, so it's 13 out of 100. For 38 to 55 matches, that's 38 and that's 55. So it is this column, not this column, this row, and this row. So it is going to be 28 add 27 out of 100. And again, I can write that in a nicer form. I can say that is 55 out of 100. Okay? Which is the modal group of the number of matches per box? For the modal group, we are looking for the number with the highest frequency in it, i.e. modal, the most popular, the most often one. So if we look back at the table, it is, let me just have a quick check, 29 to 37. So 29 to 37. Okay, the next question says, on graph paper, draw a group frequency polygon. Okay, you need to know what this term means. Group frequency polygon means it is a line graph that is plotted at the midpoint. So the two key pieces of information are line graph plotted at midpoints. Okay, if it's at a group frequency diagram, it would be a bar chart with touching bars. Okay, so looking at the previous question, or the previous table, we know that the highest frequency was 32. Okay, so on my graph here, frequency always goes up on the y-axis, and try and draw a line there, roughly, but you're going to use a ruler, don't do that freehand, please. That's going to be 10, that's going to be 20, that's going to be 30, and this will be 40, and that gives us a very nice scale because one little square is actually worth 1. And again, if I just look back at the table for a brief second, it runs from 20 to 55. Now, if I say 20 by here, and then 28 by there, and then 36, there's a big issue with that, and that's because I've just written straight from here, I've said that this block here is effectively jumping 20, so that must be 40, unless I do something like that. Okay, that's called a break in the axes, and that would allow me to then plot as I want. Okay, however, I am going to think smart about the numbers I'm putting on here. So let me just get rid of these for a second. There we go. If I get rid of those for a second. Again, look what your midpoints are. So if I go and check my midpoints on the table, I find that I run from 20 all the way up to about 51. Or 24 up to 51. So I'm going to go up here. I'm going to go up in from 20, and then 30, and then 40, and then 50, and then 60, just because it's going to make things very easy to plot. Okay, so looking at your table, look at your midpoints, and then look at where you need to plot it. So 24 and 13, so I'm looking at 20 here. There's 25, so 24 is one back, and then 13, so hopefully pretty easy to plot. So 24 and 13 there. And then as if by magic, the other points just popped up. Magicians never tell, so I'm not going to tell you how I did that, but if you ask me nicely, might show you one day. And then all we do, because it's a line graph, is we literally just join those 2 points up there, there, and there with a ruler. Okay? Okay then, so looking at a right-angled triangle, a couple of things just spring to mind straight away. Pythagoras' theorem, maybe trigonometry. But this has asked me to work out the area of the triangle. So all we need to do is we need to know a formula, which is area is equal to base times height, all divided by 2. Okay, now whenever we're talking about height, think about it. When we're talking about height, if I have got a wall here, and I'm going to measure how tall I am I going to stand up to the wall leaning like that? No, because I'm going to come out to being very, very short indeed. Okay, if I'm standing to get my height measured, I'm going to stand with a lovely straight back and standing up nice and straight. Okay, what sort of angle am I making with the floor? I'm making 90 degrees angle with the floor. Okay, so where we look for that 90 degrees, that's where our height is. So if we go and put this information in, it says BC, so B to C is 3.3. It then tells me that AB, so that is 5.6, is 5.6. So to work out the area of this triangle, I need to do base, so 3.3, times by the height, which is 5.6, or the other way around, doesn't matter which way around you do it, and then divide that by 2, okay? And that is going purely into our calculator. And I got the answer of 9.24, and that would be centimetres squared. Okay. The next one says calculate the length of AC. So as I said before, it's going to be Pythag or trigonometry. Am I given any angle other than the 90 degrees? And the answer is no. Am I asked to find any angle other than 90 degrees? No. So the answer I need to be thinking of here, or what I'm doing, is using Pythagoras. Okay. So Pythagoras states a squared plus b squared equals c squared, where opposite the right angle there, that's what we call c, is our hypotenuse is c. So to work this out, I need to do 5.6 squared plus 3.3 squared, and that would be equal to c squared. And then that is going purely into my calculator, so 5.6 squared plus 3.3 squared And I've pressed equals on my calculator to get 42.25 is equal to c squared. To get rid of the squared, I'm going to square root both sides. That's going to give me just c on that side, and square root of this answer gives me 6.5 dead on. Okay, so my answer to AC is 6.5 centimetres. Okay, and question 6 says calculate the circumference, so I'm going to stop there straight away. Circumference, there should be two formulas that you know for that. You'll know either one of these, either pi d or c is equal to 2 pi r. Okay, don't confuse it with pi r squared. That is for area. They have told me circumference. Okay, so it says the radius is 4.5. So when we're talking circles, the radius goes from the centre to the circumference. That is what we call a radius. This line here would be what we call the diameter that goes the whole way through. And the link between the radius and the diameter is the diameter is equal to 2 of the radiuses. Okay, so if I know the radius is 4.5, then by definition, I know the diameter is equal to 9 centimetres. So that way now you can use either of these formulas and it will tell you the correct answer. So C is equal to pi d, that would be pi times 9. So C is equal to pi times 9, which comes out, when I press SD, to 28.3 centimetres to 1 decimal place. Alternatively, I could have said C is equal to 2 pi r, so that's 2 times pi times 4.5, and sure enough, when you put that into your calculator, it also tells you 28.3 centimetres to 1 decimal place. Okay, this question here, this is telling us that the diameter is 14.2, so that means I know the radius. Okay, the radius must be half of that, which is 7.1 centimetres. Now we've already said, or I've already said up here, what the formula is for that. Okay, so that is area is pi r squared. There's no other form for that. You need to learn it as pi r squared. So that means pi times 7.1 squared. Common misconception, people say, oh, 7.1 squared is 14.2. No, it is not. That is 7.1 times by 2, not 7.1 squared. 7.1 squared is like 49 or higher than that, okay? So, because it means times by itself. 7.1 times 7.1, for example. So putting into my calculator pi times 7.1 squared and then pressing SD gives me an answer of 158.4 to 1 decimal place, and that would be centimetres squared, and I'd say to 1 decimal place. Okay then, this question here is the start of trial improvement, but you don't actually have to do that much. What you need to do is you need to sub in both of these values at different points. One answer should be lower than 0 and one answer should be higher than 0, and that way that shows the solution lies between 4.5 and 4.6. So I'm going to say 3 brackets cube plus brackets minus 293 equals. Okay, and then I'm going to write it again. And this is the way that we learnt to substitute in lessons when we did it as our C grade topic of the week. And the first one I'm going to put in is 4.5. So 4.5 goes in here and 4.5 goes in here. And when I put that into my calculator, I get for the first one minus 15.125. Okay, now I'm going to sub in 4.6. So I'm going to not delete the answer in my calculator. I'm using the replay button to go and delete the 5s and change them to 6s. And I get 3.608. There is no need for you to do any further calculation, but say, I need to say that I put in 4.6 here. 4.6. You need to say, as there is a change of sign, this shows that the solution, so the answer, lies between 4.5 and 4.6. Okay? Okay then, question 8, it says a six-sided polygon is to be drawn using a computer program. The designer has stated that 3 of the internal angles should be 140 degrees each, and the remaining 3 angles should be acute angles. Explain whether or not that this design is possible. Show all the reasons, or show all the working, and give a reason for your answer. Okay, so we did this recently in class. Again, you should be able to do this. Go and look at your sheet. It's stuck into your book, and it will say, it's got all the shapes on it. So it's got triangles, quadrilaterals, pentagons, hexagons, heptagons, octagons, nonagons, and decagons. Okay, you are looking for a six-sided one. So that is the hexagon. Okay, now we learned a formula which said 180 times by n minus 2, where n stood for the number of sides of the shape. Okay, so to work this out, I need to do 180 times by 6 minus 2, and put that into calculator, and you get 720 degrees. Okay, so this guy who's making this computer program, he wants 3 of the angles to be 140 degrees. Okay, that's what it tells you there. It says 3 of the internal angles, internal just means inside angles like these ones, should be 140. So that is going to give me 3 lots of 140. Putting that into my calculator tells you that is 420 degrees. Okay, so from here now, that means I'm going to do 720 degrees. I've already taken up 420 from those 3 lots of 140, and that leaves me with 300 degrees. Okay, now in terms of having acute angles have got to be less than 90 degrees. So the only way I could have it is, well, the worst case scenario then, it was one way of thinking of it, is having 89 degrees, add 89 degrees, add another 89 degrees, and that they're all just acute angles. And if I work that out, 89, well, I suppose times 3, gives me 267. So that is the worst case scenario. It can't be more than that, and it is. I found out that when I've taken away the 420, it's 300 degrees. So I'm going to say, as worst case scenario, I can never spell this word. I think of scenery, so scenario. I'm hoping that's right. As worst case scenario is 3 angles, or 3 acute angles of 89 degrees each comes to 267 degrees. The 300 degrees that is left means that it is impossible to follow these instructions. I'm just trying to think of like a better way of explaining it than I have done already. You could maybe say something like that this 300 here, that if we said, well, there's 3 angles left, so 300 degrees divided by, not by 3, but sorry, not by 1, but by 3, tells you that the average angle has got to be 100 degrees, and that's clearly above 90, so that clearly the average angle being 100 would suggest that it's also going to be impossible for them all to be acute. So I don't know if you can think of a better way of wording that. This isn't really my strong point, wording, doing worded answers, okay? So see which one you think is better, and by all means change my wording. You don't have to write word for word the same as mine, okay? Okay, then the last question then. It is a hard one to finish off, okay? So we're going to have to be on the game here. Okay, it says, a low-energy light bulb lasts 20 times longer and uses 2/3 of the electricity used by an ordinary light bulb. An ordinary light bulb costs 49p and uses £3.30 of electric over its lifetime. A low-energy light bulb costs £15. By considering the period of the lifetime of one low-energy light bulb, which type of light bulb do you think offers better value for money, and by how much? Okay then, so let's start. Okay, I would start by saying that if we know that a low energy light bulb lasts 20 times longer, then this 49p for one light bulb, I need to say, well, in that time, I'm going to get 49p times 20, because I'm going to get through 20 of the ordinary light bulbs. So 49p times 20 gives me a ridiculous answer, gives me 980 pence, which I'm going to change to £9.80. Okay? It is also going to get £3.30's worth of electricity over its lifetime. So I also need to do £330, and I go through 20 of these things. So £3.30 times by 20 is 66 quid. So when I use 20 of the light bulbs, I use £66 worth of electricity, and the light bulb actually cost me just £9.80, or the 20 light bulbs cost me £9.80. So that gives me a total of £75.80 for 20 ordinary light bulbs. And its electricity. Okay, so the other light bulb, so I'll try and work in a different colour for this. It costs 15 quid, but we're only going to get one of those in the same time. So we've got £15 for one bulb, and that lasts the same amount of time, so we no more bulbs for that one. And then it uses 2/3 of the electricity used by an ordinary bulb. Okay, so 2/3 of the electricity. So I need to find 2/3 of £66, because it's going to use 2/3 of that amount of electricity. So into my calculator, I put 2/3, and then I times it by 66, and that gives me the answer £44. So I know that the low cost, so I'll write by here, low costs, is going to be £15 the bulb and £44. So £15 plus the £44 comes to £59. So there you go, right down the 59 there. And then from there, what did the question ask me to do? It said, which light bulb offers the best value for money and by how much? Okay, so it's obvious that the low energy bulb offers better value. And by how much? Well, I need to do the £75.80 take away the £59, which is equal to £16.80.